All right, good morning, everyone. Today, I just want us to start off by practicing with more slope fields. So if you don't have this printed out, that's fine. We can just, basically, I'm just going to be trying to list out as many properties as I can, and then using the properties to helpfully eliminate wrong choices. I think it's faster to eliminate the wrong choices than to look for the correct one, right? If we can quickly eliminate the wrong ones, then if we're down to one or two, then we can look at some specific order pairs to help us finalize our correct choice. So one of the restrictions that we have with slope fields in terms of determining is that we don't know exactly the numeric value for all these slopes, right? We know that, if you're looking at this, we know that that's going to be a relatively steep slope, but it could be -7, it could be -9. We don't really know. But what we can figure out are these four things. I'm going to write out, some of the general characteristics that we're able to gather. Okay. We can definitely tell when there's a slope 0. So we're looking for where slope is equal to 0. Where is there a collection of them? Okay. Another thing that we can tell is where there's a slope, where there are slope undefined. And slope undefined would just be a collection of empty spaces, right? So I want to point something out here as we're doing this, is that sometimes you may be looking at something that looks like, okay, looking at this, maybe thinking that maybe that represents slope undefined. But if it looks like a vertical line, that means it's really, really steep, okay? Because if it's truly a vertical line, it shouldn't be there at all, okay? So I think that was a good question that someone asked previous periods, like, how do we know that these are not slope undefined? Because if it's truly slope undefined, it shouldn't even show up, okay? So that's how we can tell slope undefined if there's a collection of empty spaces. Another easy one to tell is looking for positive slopes. All right, we can tell positive slopes, even though we may not know the exact value, we can visually see where there's a positive slope. And then where is there a collection of negative slope? So those are four things that we can quickly look for. All right, so let's see if we can find those things here. Okay, so listing out characteristics here: slope 0, slope undefined, positive slope, and negative slope. Now, you may not have to go through, and look for it every time for every one of these, but just want to kind of give you some guidelines to help you gather information and help you organize and quickly get to the answers. So let's start off with slope 0. Do we see a collection of slope zeros on this slope field?
On the x-axis.
On the x-axis, okay. Now this problem is a little bit nicer because it actually it's not hiding that information, right? We can kind of see the accented lines there. So, but just be aware, sometimes you have problems where you can't really tell. So just be aware that sometimes x-axis hides information, forcing us to look elsewhere to gather information. But in this case, that we can tell, so we'll say slope equals 0 when on the x-axis when y equals 0. Okay, do we see any places where there's slope undefined?
On the y-axis?
Yeah, y-axis, right? If it truly was a slope, we should see some sort of a tick mark, right? Either horizontal or diagonal. We don't see anything there, so. Do we see a collection of positive slope? None. So that's a good property, right? That means if any of these produces any positive value, we know it must be false, right? So none. How about negative slopes?
The whole.
Yeah, mostly, right? Looks like it's mostly outside of these exceptions with 1 and 2, right? Mostly negative slope. So when there's such a big broad statement like this one, where there's no positive slopes at all, we should be able to use that to eliminate a lot of wrong choices, right? But I mean, we can also look at these other ones as well. So let's start with the first one here. Slope equals 0 when y equals 0. Do we see any that contradicts? Where if I plug 0 in, I'm not always getting a 0 when I replace y with 0.
All of them should equal 0 except C.
Yeah, so C doesn't quite fit that, right? So I can eliminate this one because if y is 0, I'm actually getting x squared over 0. That's not going to be 0, right? So, all right, so that part C contradicts the first statement. Okay. Second one here, when x equals 0, I should be getting slope undefined. When x equals 0, I should be getting slope undefined. Which one can we eliminate?
And
Yeah, because if I replace x with 0, I'm not getting undefined, I'm getting 0. So undefined is only going to come where there's a denominator. There's no denominator for a and b, so looks like this one's out. Okay, last one here. So it looks like we're able to eliminate choices just by looking at the first two. We didn't have to get through the positive slope. But we can convince ourselves, right, that this makes sense. There's no positive slopes here because x squared and y squared are always positive. That fraction is always positive, which is going to force this to always be a negative because there's a negative outside. So mostly negative, no positive, right? Just extra confirmation that D is the correct answer choice. Okay. Some of the more difficult ones are where you list all the properties out, you're down to two choices, and you may have to look at some specific order pairs and say, okay, I know 1, 1 is giving me positive, so let me test 1, 1, see if I can get something to see information to be different. And if that order pair doesn't work, then I may jump to another order pair. And I think we're going to see one of those where the difference is not as obvious as what we saw here. Okay, any questions with one? Okay, number 2, same thing. We're going to go down the line and list out properties that we can identify. So let me list them out. Slope 0, slope undefined, positive slope, negative slope. Okay, do we see any slope zeros?
along the y-axis.
Yeah, it looks like the y-axis. Pretty sure that's slope 0. Those aren't tick marks. Looks like it's consistent with the lengths that we see on either side. Okay, so slope 0 when x equals 0. Do we see any slope undefined?
When y equals 0.
Maybe, right? We got to say that as a maybe because it's either undefined or not really steep, or these are tick marks. You're right, yeah. Or it could be really steep, or it could be slope 0 that's being hidden by the x-axis. But yeah, you're right. Maybe it's either really steep or undefined. So we'll put a question mark there. Okay, so maybe y equals 0. But I think you're right. I think these are actually really steep slopes. Okay, so we'll put a question mark there. We're not sure about that one. Okay, how about positive slopes?
The whole graph.
Pretty much, right? Pretty much the entire graph are just variations of positive slope. So mostly entire graph, which means there's any negative slopes? None. Okay, let's look to eliminate some choices here. When x equals 0, I should be getting 0 in return. Which one is not going to be consistent with this first statement here?
B.
Yeah, when x equals 0, anytime I see a 0 in the denominator, I know that can't be a 0 overall. Okay, so that's nice. We can eliminate two choices just by looking at the first characteristic. Let's skip the second one. We really don't have a strong sense that this is true. Mostly positive slope, no negative slope. So if I can even identify an ordered pair that will give me a negative slope, I can eliminate that one. So which one has the potential of giving me a negative number in return?
1, 1.
Yeah, for the first one, right?
Yeah.
If I do 1, 1, you're right. I'm getting a negative number. And if I get a negative slope, that's not consistent. Kind of contradicts that fourth statement. So we know this one is not true, not the right one. What other one? Oh, that's it, right? So we're just left with x squared over y squared. Okay, let's test this out. Let's make sure this is correct. When x equals 0, yep, that's 0. Positive slope, mostly the entire graph. Yeah, x squared over y squared is pretty much always positive, unless x or y is 0. And negative slope, no negative slope here. Yeah, so it does end up being undefined at 0. When y equals 0, we do get undefined. So yeah, looks like this must represent the tick marks and doesn't represent slope undefined. Oh yeah, it's slope undefined. Okay, questions? All right, let's do 2 more. Slope 0, slope undefined, positive slope, negative slope. All right, do we see slope zeros?
It seems like along y equals 2.
Mm-hmm. Yeah, that's what I see as well. Yep, along this line, right? Okay. Do you see any slope undefined?
It could be at y equals 0, but we don't know. Or no.
Yeah, I think these are going to be slope values here because of the slanted lines there, diagonal lines. So, and those look like. Actually, is there actually? Yeah, I think these are actually tick marks. So we'll ignore what's happening here. It's not very very clear. Maybe it's slope undefined on the y-axis, but we'll leave that alone. All right, how about positive slopes?
Quadrant 1.
Mostly, right? Mostly quadrant 1, as long as it's above y equals 2, and then mostly quadrant. Positive slopes? 3, right? So mostly, right? Now we know that it's not for for sure. Well, we do have some exceptions, right? Because of the fact that it's above. We know something above and below the line. There's things are definitely changing on either side of the line, but at least we can make some general statements. So mostly, mostly quadrant 1 and quadrant 3. Negative slopes.
Quadrant 4 mostly.
Yeah, and it's mostly 2 and 4. All right, let's go down the line here. When y equals 2, I should be getting a 0 in return. Which one can we take out?
A.
Yeah, if I plug 2 in, getting x squared over 0, that's undefined. That's not the same thing as 0.
And that's it.
I think I have one more that I see is not going to give me a 0 when I plug 2 in. Do you see another one that we can eliminate based off of this first statement?
Oh yeah, D.
D, right? If I plug 2 in, I'm getting -4 over something, and that's not the same thing as 0. So that's nice. Just having one characteristic eliminate 2 choices for us. Slope undefined, it's not very clear because of the tick marks and because of the axis hiding some information. Positive slope, I think we may have to just look at some order pairs now. Just going to pick a random order pair. What if I pick something in the first quadrant up here? Like 3, okay, let's test that. So we'll test 3, 3. We know 3, 3 should be positive, right? We should get a positive return. Okay, let's test 3, 3. Okay, so if I put 3 in here, I get a negative 9 times 3 minus 2 squared, which is positive. So negative times positive is negative. So I think B is out, right? But let's test 3, 3 with the third one just to confirm. This should be positive. So 3 in for X, I get positive. 3 in for Y, I get positive. So yeah, looks like C is the right one. I can eliminate B just by testing 1. But just be aware that sometimes not every order pair that you test may get a different result. So you may have to, just jump around and look at different quadrants and test them. Okay, any questions? Okay, one last one, number 4. We'll look for slope 0. We'll look for slope undefined. We'll look for positive slope, and we'll look for negative slope. Okay, do you see any slope zeros? Yeah, it's either the y-axis or those are tick marks, right? So yeah, we'll say question mark. Maybe when x equals 0, but we don't know if it's a tick mark. That's what we're looking at. Slope undefined.
Or y.
Yeah, so that's obvious, right? We see a whole like blank slot here. That's indication that slope is undefined. Positive slopes.
Quadrants 4 and 2.
Yeah. Negative slopes.
Quadrants 1 and 3.
Yeah. Yeah, we'll skip that first statement. We don't know. We're not very sure about that. But slope undefined, definitely when y equals 1. So which one is one that is not showing that as a property? Yeah, if I put 1 in here, I'm getting 0 over x, and that's not the same thing as undefined. But it looks like A, C, and D are still in play. Okay, so this one is a little bit harder to eliminate. Let's look at some order pairs here. Positive slope, let's pick something from quadrant 2. What point can we test?
Negative 1, 2.
Okay. Negative 1, 2. Yeah, so negative 1, 2 should give me a positive slope. Okay, let's test that out. Okay, negative 1, 2. Yep, that's positive. Negative 1, 2. That's positive. Negative 1, 2. That's still positive, right? Okay, so not much progress there. What if something in the first quadrant? What if we test a little bit further out here? 4, 2. And we should be expecting a negative number out of 4, 2. So 4, 2, that's negative. 4, 2, also negative. Oh, 4, 2, we get what? Positive. Okay, so I can take 1 out. So the only difference is that y minus 1 is being squared. So what if I force something where y is going to give me a different value? Something that has y equals 0. Because when y equals 0, 1 is positive, the other is going to be negative, right? So what's an order pair that I can use with y equals 0?
Maybe something in the third or fourth quadrant.
Okay.
So like negative 1, negative 1.
Yeah, that's good. Negative 1, negative 1. All right, let's test that out. Negative 1, negative 1. I get a positive over a positive. That's positive. I get a positive over a negative, that's negative. So a negative 1, I should be expecting negative. So positive is going to be out. This one is out. Let's see. Yeah, so sometimes you may want to look at characteristics, and if they're really close, choose something that will force a different output, right? If you choose something that will give you a different output, then you can use that to help you eliminate and get down to your right answer. Yeah, so it's a little bit of guess and check, but hopefully we can minimize guess and check if we can remove some of the obvious wrong choices. Okay, so any questions? Let's move to the slope fields additional notes. Really, I'm gonna skip the domain portion. Maybe I think I'm not gonna have it on the test. Maybe have it. Maybe we'll cover it after when we get into our review cycle. But we're just going to look at number 1. We're going to practice solving differential equation. And we're going to review some topics from first semester, tangent line equation, and approximating. So I'll put this on a separate sheet so you guys can see things a little more clearly. Okay, so we're going to find a particular solution. We'll skip the domain portion. We'll find the tangent line equation. And we'll approximate, linear approximation. Okay. All right, find a particular solution. We're going to be solving this differential equation. What's the first thing that we can do?
Rewriting the equation to have x's on one side.
Okay. What's a quick way that we can get the denominator to go away? Yeah, so I like to just cross multiply. At least cross multiply is not going to separate the variables, but it's going to instantly put the dy and dx's in their locked in their appropriate spots. So that's why I like to cross multiply. I like to just get everything in the numerator, and at least I can get the dy and dx set. Those should be ready to go. So dy, dx, those are, we can concretely say that those are in the right spots, but do we have full separation yet? Okay, we're one thing away, right? We have to move what?
The x.
X squared, right? Divide the x squared over, okay? All right, how about now? Do we now have full separation? Y is on one side, x is on the other. Okay, good. So dy, dx are in the right spots. It's okay to have x's in the denominator. But now, as we are going to explore our integral, our antiderivative, we do need to make some adjustments, right? Because I'm looking at both of these sides, I'm thinking power rule for both. Left side is ready to go. How about the right side? Yeah, good. So if we want to do power rule, the only way power rule is going to work is if the variable's in the right position. It needs to be sitting in the numerator. So it's okay that x squared is in the denominator. You know, because we just want to know if it's in the right spot in terms of separation of variables. But once it's in the right spot, we may have to move it again, depending on what rule we're trying to apply. Okay, now both sides are ready to go, right? Power rule for both. Okay. Y squared over 2. What does the right side become?
-1 over x.
Okay, good. Okay, yeah, I'll get there eventually. Right now, I'm just going to leave it in this form, but yeah, we're going to clean that up just in a little bit. All right, questions so far? All right, so you've earned a lot of points up to this point because you've shown knowledge of separation of variables. You took the antiderivative correctly, plus c shows up. This is basically a very rough version of the answer, but the rest of it is just refining it, right? We've gotten the most important part down already. Okay, good so far? Okay, so I want to solve for y. I see y squared. If I see y squared, I know there's a square root coming up. And if there's a square root coming up, I would prefer to get that c resolved before I got to deal with that square root. So I know I'm going to solve for c a little earlier in this problem. But one thing I like to clean up the left side as I see if I see anything that I can move. So I'm going to deal with that too first. It's just my preference. I like to keep that left side as clean as possible. Just makes it less cluttered when I get down to it. So I'll distribute the 2 through just to get that down to a y squared. And I get negative 2x to negative 1 plus c. Okay, y squared. I know square root is coming up, but I want to solve for c earlier. Okay, let's do a little bit of cleanup, like you guys mentioned. Bring that x down. Okay, so now, before the square root shows up, I'm going to get that c taken care of. So we'll put -1 in for x, put -2 in for y. Solve for c. C equals 2. Okay, we'll update our equation. So I replaced x and y at this step. So this is where I'm going to replace c at the same step. Now I can involve the square root. Right? I've cleaned up everything. There's nothing else I need to solve. Now I don't have to deal with that square root, or at least what's inside of it. Okay. Careful though, what do we have to make sure we keep track of? Yeah, there's a plus or minus here, right? Put this down here. All right, so plus or minus, which means that we have 2 potential solutions, and we're going to choose between one of them. All right. It's not going to be both. It's going to be one or the other. All right, so we have our 2 options. Which do we choose? How can we?
Yeah, negative.
Okay, why?
Because the y is negative.
Good. We go to the order pair. That's a quick way to tell. Whatever the sign of the y value is, it's going to be the sign of your answer. If it's a positive y value, then choose a positive square root. If it's a negative y value, then you'll choose a negative square root. Okay, questions with the solution, particular solution, part A. Okay, we're skipping domain. Let's do tangent line equation. Now this goes back to first semester a little bit. What information do we need to find the tangent line equation?
The slope,
And
the x and y
yeah,
values.
good. So we need order pair and we need slope, right? So we need order pair and we need slope. Order pair given to us, so that's easy. Now, first semester, we found slope using f prime, right? A derivative function, we'll plug that in and we'll get that order pair. Sorry, we'll get a number and that number corresponds to slope. We don't have f prime per se, but what do we have that is essentially the same thing?
The dy dx.
Good. That is the derivative, right? We call it a differential equation, but it's basically serves the same purpose as f prime, as derivative function. It's not quite a function, but it still helps find the slope for us. So that is how we're going to arrive at the slope. Okay, use the derivative equation, differential equation. So I'm going to write the formula here. Put -1 in for x, -2 in for y. And that just cleans up to be -1/2. So I have my order pair. I have my slope. Now we just do point slope. Okay. Replace the x1, y1 with -1, -2. Replace the m with -1/2. Clean this up. So here's our tangent line equation. Pretty much first semester material, we just have to understand that our derivative equation may look a little different, but same idea, right? It's a slope formula, regardless if it's an f prime form or whether it's shown as a dy dx. Okay, questions there? All right, part D, we're going to approximate y of -1.1. Linear approximation, it sounds like a complex thing, but really you're just doing one little thing more than tangent line equation. You're just dumping that, replacing the x value with a decimal that you're given. So all we're going to do is we're just going to take this -1.1 and put it in place of the x. And then once we solve for y, we can get a decimal value. So think of it as just one additional step past the tangent line equation. So let me rewrite the equation first. Y is equal to, get that y by itself. And now y of -1.1, all I'm going to do is take that x and put -1.1 in place of it. Okay, so here's my tangent line equation, just making a small little substitution, and that will allow me to get to a decimal number, and that's my approximation using the tangent line. Okay, do you guys get -1.95? Check. Yeah. All right, any questions? Okay. Yeah, just one final announcement to make. Where did it go? Yeah, I pushed the recovery test date to next Monday. So the recovery assignment was going to be due tonight, but we'll make it due on Friday instead. I'm still having a health session. I had it this morning. It's recorded. I'll have it this afternoon and Friday as well for anyone who wants me to go over Chapter 4 test material. Recovery test is on Monday. I updated the team's assignment details, so make sure you're letting me know which time you want to select, either 7:15 or 4:30 in the afternoon if you want to do a test recovery up to 79. Some slight adjustments coming up as well. Our Chapter 5, 6 tests. I initially had it as Wednesday, but it's going to be Thursday. Okay. Chapter it was Wednesday, but I'm going to make it. We're going to make it Thursday instead. Just have a full day, a full class period. Wednesday's a little bit short. And is there anything else? Chapter 5, 6 test. Yeah, I thought there was one more thing, but oh yeah, I'm still finishing up on grading your 5.2, 5.5 quiz. Most of you guys did really well on it. I just have to finish it up. Hopefully, if not tomorrow, I can get your grades back by Friday. Okay. Okay. Any questions? Okay. Thanks everyone. Hope you guys have a great day. See you tomorrow.